Welcome to Math on Ice, December 2017 Integral Equations. There are two questions from part C. There is no question from part B. So the first question, let phi be the solution of the integral equation half phi of x minus integral 0 to 1 e to the power x minus phi of y dy is equal to x squared. This is an Fredholm integral equation. We need to find f of 0 and phi of 0 and phi of 1. So half of phi of x is equal to x squared plus integral 0 to 1 e to the power x minus y into phi of y dy. So phi of x is equal to 2x squared plus 2 into integral 0 to 1 e to the power x into e to the power minus y into phi of y dy. So phi of x is equal to 2x squared plus 2 into e power x can be taken outside, integral 0 to 1 e to the power minus y into phi of y dy. So let me take c is equal to integral 0 to 1 e to the power minus y into phi of y dy. So we get phi of x is equal to 2x squared plus 2c e to the power x. Now c will be equal to integral 0 to 1 e to the power minus y. Phi of y will be 2y squared plus 2c e to the power y into dy. As phi of x is equal to 2x squared plus 2c e to the power x, we get phi of y to be 2y squared plus 2c e to the power y into dy. So c is equal to integral 0 to 1 e to the power minus y 2 into y squared plus 2 e to the power minus y c e to the power y into dy. So c is equal to 2 can be taken outside, integral 0 to 1 y squared into e to the power minus y dy, and then plus 2c e power minus y and e power y cancels, we get 1. So integral dy. C is equal to 2 times of, we solve this by UDV method. Let me take u is equal to y squared. So I get du is equal to 2y into dy, and then e to the power minus y is equal to dv, this one into dy. So we get minus e to the power minus y is equal to v. uv minus integral v du. U is y squared, v is minus e to the power minus y, uv minus integral v du, or v is minus e power minus y, so plus e to the power minus y into, we get du is equal to 2y into dy, plus this limit is also from 0 to 1, right? So 2c y 0 to 1. So c is equal to 2 times of, when I put 1 here, minus 1 e to the power minus 1. So we get minus e to the power minus 1. And when I put 0 here, fully it becomes 0. So no need to substitute. Plus integral 0 to 2 can be taken outside, integral 0 to 1 y into e to the power minus y into dy, and then plus 2c into, when I substitute the limits, I get 1 here. Now bring this 2c to the left side, we get c minus 2c is equal to 2 times of minus 2 times of e power minus 1 plus 2 2s are 4 times of integral 0 to 1 y into e to the power minus y into dy. So this will be minus c is equal to minus 2 e power minus 1 plus 4 times of, now again u is equal to y, so we get du is equal to dy, and then e to the power minus y dy is equal to dv. When you integrate, we get it as minus e power minus y is equal to v. So this will be u is actually equal to y, v is equal to minus e to the power minus y, lower limit, upper limit, minus integral v is e to the power minus y, v, du will be equal to dy. Limit is from 0 to 1. So minus c minus 2 e power minus 1 here plus 4 times of, when you apply the upper limit, we have it as minus 1 e to the power minus 1. So minus e to the power minus 1. When you apply the upper limit, we got minus e power minus 1. When you apply the lower limit, we get 0 plus integral e to the power integral of 0 to 1 e to the power minus y will be e power minus y and a minus lower limit and upper limit. So this is equal to minus c is equal to minus 2 e to the power minus 1 plus 4 times of minus e power minus 1 and then minus e to the power minus y 0 to 1. So that is equal to minus c is equal to minus 2 e power minus 1 minus 4 e power minus 1 then minus 4 e power minus 1 minus e power 0. So when you cancel negative from the both left hand side and right hand side, we get c is equal to 2 e power minus 1 plus 4 e power minus 1 plus 4 e power minus 1 then minus e power 1 e power 0 is 1, so we get minus 4. So this is what our c is. C is equal to 10 e power minus 1 minus 4, that is c is equal to 10 by e minus 4. What is our phi of x here? Phi of x is equal to 2x square plus 2c e power x. As phi of x is equal to 2x square plus 2c e power x, we get it as 2 into x squared plus 2 into e power x and then 10 by e minus 4. In the option, we need to find phi of 0 and phi of 1. So phi of 0 is equal to 2 into 0 squared plus 2 into e power 0, 10 by e minus 4, that is equal to 20 by e minus 8. So we get 20 by e minus 8, 20 e inverse minus 8, 20 by e. So first one is true, second one is false. Now we will find phi of 1. So phi of 1 is equal to 2 into 1 squared plus 2 into e to the power 1, 10 by e minus 4. So that is equal to 2 plus 2, 20, e cancels each other and then we get 20 minus 4 2s are 8e. We get 20 plus 2, 22 minus 8e. Phi of 1 is equal to 22 minus 8e. 22 minus 8e. So the third option is true, fourth is false. So the first option and the third option are the correct options. Next question from part C. Consider a non-zero real valued polynomial function p of x is equal to a naught plus a1x plus a2x squared of degree at most 2. Let y is equal to y of x be the solution of the integral equation. Which of the following statements are necessarily correct? Y of x is a polynomial function of degree less than or equal to 2. Y of x is a polynomial function of degree less than or equal to 4. And then they have given conditions on a1, a0 and a2. Then we need to verify for y dash of 0 and y double dash of 0. We solve the problem by Leibniz rule. Y is equal to p of x plus integral 0 to x sine of x minus t into y of t dt. So y dash of x is equal to, this is actually y of x. So y dash of x is equal to p dash of x plus taking the Leibniz rule integration, we have this as integral 0 to x. Differentiation of sine is cos of x minus t into y of t dt. And then for the upper limit, we have it as differentiation of x to be 1. And then sine of x minus x, y of x, minus the lower limit is 0. Differentiation will give you 0. So y dash of x is equal to p dash of x plus integral 0 to x cos of x minus t into y of t dt. The sign of x minus x will vanish, so everything will will be 0 here in the next terms. So integral 0 to x cos of x minus t into y of t into dt. Next, we need to take double derivative. Y double dash of x is equal to p double dash of x plus integral 0 to x. Differentiation of cos is minus sine. So minus sine of x minus t into y of t dt. And then plus cos of x minus x and y of x minus 0 minus 0. So this will be equal to p double dash of x plus integral 0 to x minus sine of x minus t into y of t dt. This cos of x minus x will be 0, cos 0, which is equal to 1. Cos 0 is 1, so simply y of x. Now when we see y of x minus integral 0 to x sine of x minus t into y of t, we will see that it is equal to p of x. When you bring this integral term to the left side, we get y of x minus integral 0 to x sin of x minus t into y of t dt, that is equal to p of x. So for these two terms, we can replace it by p of x. Hence, we get y double dash of x is equal to p double dash of x plus p of x. Now, what is given in the question? P of x is equal to a naught plus a1x plus a2x squared, right? So we will use this. P of x is given to be a naught plus a1x plus a2x squared. A naught plus a1x plus a2x squared. We need p of x and then p double dash of x. P dash of x will be equal to a naught will vanish, so we get a1 plus 2a2x, and then p double dash of x is equal to a1 vanishes, so we get 2a2. So this term will be equal to 2a2 plus what is our p of x? It is equal to a naught plus a1x plus a2x squared. Here the constant term is a naught plus 2a2, and then x term is a1, and then x square term will be a2. The coefficients are this way. So y double dash of x is equal to 2a2 plus a naught plus a1x plus a2x squared. Y of x is a polynomial of degree less than or equal to 2. We need to verify. It is given that we have found that y double dash of x is equal to 2a2 plus a naught plus a1x plus a2x squared. Now we will verify for y of x. Y dash of x will be equal to, now take the integration, we get it as 2a2 plus a naught the whole thing into x as it is a constant plus a1 x squared by 2 plus a2 x cube by 3, and then for y of x we again take the integration. Y of x is equal to 2a2 plus a naught the whole thing into plus c1 will be there, so we get x squared divided by 2 plus a1 x cube by, already we have a 2 here, and then this 3 again. Now a2 x power 4 divided by, already a 3 here and a 4 will come, plus c1x plus c2. So y of x is equal to, we got it as powers of 4, x power 4, a2 divided by 4 3s are 12 into x power 4 plus x, for x cube we have it as 6, a1 divided by 6 into x cube. For x squared we have 2a2 plus a naught divided by 2 completely for x squared, and for x it is c1x, for the constant term we have c2. This is a fourth degree polynomial. So y of x, the polynomial of degree less than or equal to 2 is false. The second option is true. Y of x, the polynomial of degree less than or equal to 4. Now, if a1 is not equal to 0, then what? And a0 plus 2a2 is equal to 0, then what happens to y dash of 0? Let us find c1 and c2. So, as you can see from here, we will use this one and this question, y of 0. What is y of 0? Y of 0, when you solve, you will get it as p of 0. We will have this condition, p of 0 for y of 0. And for y dash of 0, we have it as p dash of 0. We will take it as initial conditions and we will find c1 and c2. Y of 0 is equal to, we got it as p of 0. So as we know, p of x is equal to a naught plus a1x plus a2x squared. We have p of 0 is equal to a naught. And then p dash of x is equal to a1 plus 2a2x. So p dash of 0 is equal to a1 here. Yes. Now y of 0 is equal to p of 0. Y dash of 0 is equal to p dash of 0. So here in this option, when I apply y of 0, y of 0 is equal to, here 0, here 0, here 0, and we get C2, and that is equal to P of 0. What we got as P of 0? P of 0 is equal to A naught. So C2 is equal to A naught. And then when I apply y dash of 0, y dash of 0 is applying 0 in this equation. So 0, 0, 0 here, only leftover thing is C1. So C1 will be equal to, what is y dash of 0? That is P dash of 0, which is equal to A1. So we get this equation y of x as, y of x is equal to a2 by 12 into x power 4 plus a1 by 6 x power 4, x power 3 plus 2a2 plus a naught divided by 2 x squared plus c1 is actually a1x plus a naught. This is what our solution is. Now, if A1 is not equal to 0 and A0 plus 2A2 is equal to 0, what happens? If A1 is not equal to 0 and A0 plus 2A2, right? A0 plus 2A2 is equal to 0. A0 plus 2A2 is equal to 0. Then we have to find the y of y dash of 0 is equal to 0 or y double dash of 0 is equal to 0 or not. This is what we have to verify. This is to be verified. This is to be verified. So let us verify each options. If A1 is not equal to 0, then what happens here? Y dash of 0. What is y dash of x first? Y dash of x is equal to y dash of x is equal to 2a2 plus a0 into x. Here we have this condition. Y dash of 0. When I apply 0 here, I will find this term to be 0, this term to be 0, this term to be 0, because all these terms contains x. When I put x is equal to 0, this vanishes. I'll get only c1, and c1 is actually equal to a1. So y dash of 0 will be equal to a1, and given a1 not equal to 0 in the given condition. So it can never be equal to 0. Y dash of 0 is not equal to 0. But given that in option 3 that it is equal to 0, so this option is wrong. Third option is wrong. Now we shall verify for y double dash of 0 is equal to 0 or not. Y double dash of 0. What is y double dash of x? Y double dash of x is equal to 2 a2 plus a0 a1x plus a2x squared. When I apply y double dash of 0, what happens here? Y double dash of 0, this term vanishes, becomes 0. This term is also 0, and only the leftover term will be 2a2 plus a0. As we know that a0 plus 2a2 is equal to 0. A0 plus 2a2 is equal to 0. This is obviously 0. So this is equal to 0. So the fourth option is true. This option is true. So only correct options are second and the fourth one. Thank you.